Synthetic substitution is very useful when you have to evaluate a polynomial. In this example, we are going to evaluate this polynomial when x is -3. So it's basically synthetic division, but we use it to evaluate polynomials. So I already know that x equals -3, so that was going to go inside of the little box. And then I'm going to write the coefficients of the polynomial. So the one for x cubed is 1. The coefficient for x squared is 3. I don't have a coefficient for x, so I'm going to write 0. Remember, we have to add placeholders. Then 4 for the constant. Then I'm going to bring the 1 down. -3 times 1 is -3. 3 minus 3 is 0. -3 times 0 is 0. 0 plus 0, 0. -3 times 0, hey, what do you know? 0 again. 4 plus 0, 4. That's the remainder. And the remainder is the value of the function when p is -3. So how do you write your answer? You're going to write p of 4. So the value of the polynomial when x, I'm sorry, I made this wrong. The value of the polynomial when p is -3 equals 4. And that's the answer. Let's try another example. We are going to evaluate p of x equals 5x squared plus 9x plus 3 for x equals 1/5. So then we know that 1/5 is going to go inside of the little box. Then we're going to write the coefficients. So it's 5 for x squared, 9 for x, 3 is a constant. I write the bar. I'm going to drop the 5. And we're going to start multiplying. 1/5 times 5 is 5/5, which is 1. 9 plus 1, 10. 1/5 times 10 is the same thing as 10/5, which is 2. 3 plus 2, 5. So the remainder is 5. That means that the value of the polynomial when x is 1/5 is 5. If you were to plug in this value into each one of these, wherever you see the x, you will get the same answer, but it will be more work. So this is easier, this is faster. Let's try another one. We're going to evaluate the polynomial p of x equals 2x to the power of 3 plus 5x squared minus x plus 7 for x equals 2. So again, the 2 goes inside the little box. We're going to have 2 for x cubed, 5 for x squared, -1 for x, 7 for the constant. So I'm going to bring the 2 down. 2 times 2, 4. 5 plus 4, 9. 2 times 9, 18. -1 plus 18, 17. 2 times 17, 34. 34 plus 7, 41. So the value of the polynomial when x is 2, so p of 2 equals 41. Let's try one more polynomial, and it's going to be the polynomial p of x equals 6x quartic minus 25x cubed minus 3x plus 5 for x equals -1/3. So again, -1/3 goes inside the little box. And I'm going to write the coefficients. 6 for x to the 4th, -5 for x to the 3rd, 0 for x squared, negative 3 for x, 5 for the constant. So I'm going to drop the 6 down. Negative 1 over 3 times 6, it's going to be the same thing as negative 6 over 3. Negative 6 over 3 is negative 2. So negative 25 minus 2 is negative 27. Negative times negative is positive. 27 times 1 over 3 is the same thing as 27 over 3, which is 9. 0 plus 9, 9. Negative 1 over 3 times 9 is going to be negative 3. Negative 3 minus 3, negative 6. Negative 1 over 3 times negative 6 is going to be positive 2. 5 plus 2, 7. So that means the value of the polynomial when x is negative 1 over 3 is 7. And that's it.